Hey guys, today's lesson is all about interpreting linear relation graphs. Specifically, we're going to spend a lot of time looking at the intercepts of graphs, both how to read them, calculate them, and use them. And what that means is essentially where the line that you're graphing, so your linear relation, where that actually hits your axes. So that's what we're going to be getting into today. Okay, so we're going to start with just some definitions. So a linear relation, as we talked about already, is any graph that is a straight line. So all graphs of straight lines are linear relations. A linear function is all graphs of straight lines except for vertical lines. And that's because a vertical line does not pass the vertical line test that we use to determine if something's a function or not. A vertical line would have multiple points on a vertical line in the vertical line test. And then our definition of intercepts, the x-intercept is where the line hits the x-axis. The y-intercept is where the line hits the y-axis. And possibly even more importantly, the y-intercept is also the b value in y equals mx plus b. So this is our kind of general equation of a line. It's called the slope-intercept form of the line. So our m value is our slope, which we talked about a few lessons ago, and our b value is our y-intercept. We can obviously read these directly off of a graph. So our y-axis is the vertical one. The point where the y-intercept is just where the line hits the y-axis. So that is 0.03. And then our x-intercept is just where the line hits the x-axis. That is 0.01. You will notice that with intercepts, with the x-intercept, the y value is always 1, and with the with the x-intercept, the y value is always 0. With the y-intercept, the x value is always 0. And we're going to use that information to calculate intercepts when given just the equation of the line. So if you're given the equation of a line, you can calculate the intercepts one at a time by subbing in a 0 for the x or y and then solving for the other variable. And again, the reason that works is because if I am solving for my x-intercept, my y value will be 0. If I'm solving for my y-intercept, my x value will be 0. Okay? You can also then use those points to actually draw the line just by connecting the two intercepts with a line. So let's go over an example of how that kind of calculation would work. Okay, so I've given you an example here where I've asked you to find the intercepts of the equation y equals negative 2x plus b. So if I'm finding the x-intercept, my y value is going to be 0. If I'm finding the y-intercept, my x value is going to be 0. So I started by just writing out what my equation is, and then plugging in a 0 for the y if I'm solving for the x-intercept, and plugging in a 0 for the x if I'm solving for the y-intercept. The y-intercept is always going to be the easiest one to solve for, because when I plug the x in here as 0, negative 2 times 0 is just 0, and then 0 plus 4 is 4. So feel free to skip these steps, because remember, if I write out my equation y equals mx plus b, my b value is always going to be my y-intercept. And I can then write that as a coordinate because I know that my x value is 0, and I just solve that my y will be 4. The x-intercept is a little bit more complicated. We are going to have to isolate x using opposite operations. So I'm going to move the positive 4 first. Because it is a positive 4, I will subtract 4 to move it. And then what I do to one side, I must do to the other. So I then have 0 minus 4 equals negative 2x. 0 minus 4 is just negative 4, so negative 4 equals negative 2x. And then from here, I can isolate the x by dividing by negative 2. And negative 4 divided by negative 2 is just 2. So my coordinate there would be 2, 0. Okay, because remember it's always xy, xy. Okay, so the next thing you have to do is be able to match an equation to a graph. When you're doing this, you're going to want to find the rate of change on the graph using either rise over run or your formula for slope. And then whatever that rate of change is in your equation, it should be in front of the x. And then you also have to find your y-intercept on the graph. That is going to be a constant in any equation that you have. So let's just look at what that would look like. So the first thing that I'm going to do is figure out what the slope of this graph is, and I'm going to do that by using rise over run because my scales are both the same on both axes, so that'll be nice and easy. So in order to figure out what my rise over run is, I'm going to pick any 2 points. So I'm going to pick this point right here and this point. And again, we always read from left to right. So I'm going to say, how many spots down, because that would be my rise, do I have to go to get from one point to the next? And I'm going to have to go down 1, 2 spots. So my rise is negative 2. And then my run is how far to the right do I have to go? And that is 1. And then I can simplify that just by writing negative 2. So I know that my slope is negative 2. I'm then going to figure out what my y-intercept is, which is my b value. And for that, I just find where my line hits the y-axis. So that is right there. And I just read off what the y value is. So that would be negative 1. Now I'm going to look over here and figure out which one of these equations has a slope of negative 2 and a b value of negative 1. Well, as far as my b values go, I can cross this one off right away because that's a positive 1. This is correct. This is correct. And this is correct. All of those are negative 1 constants, which means that it's a negative 1 without a variable, so without an x or a y or anything. Even though this first one isn't in the order that we normally see it in, where the b is at the end, it's still a constant, so it still counts, it's just in a weird order. And then I'm going to look for which one has a slope of negative 2, which means in front of my x, I need a negative 2. So here's my x, in front of it is a negative 2, because remember the symbol goes with the term behind it, so this is a negative 2. This is out because that's a positive 2. That's out, that's a negative 0.5. And this one would also be okay, that's a negative 2. So the only one that has both the b value and the slope in the right spot is equation A. I have intentionally swapped the order of my mx and my b to try and trick you guys, but that is what it should look like. Okay, so the last thing that we're going to be looking at today is how to solve word problems that involve graphs of linear functions. So your first step should always be to write the equation of the linear relation if it's not given to you. And in order to do that, you'll have to identify the y-intercept and calculate the slope. Once you have the linear relation equation written out, then you're going to plug in either the x or y value that you were given in the question and then solve for the unknown variable. So in this question, I've given you a distance time graph, and I've asked how many minutes will it take to travel 15.7 kilometers. So again, our first step is going to be to write out our equation in y equals mx plus b form. And in order to do that, we're going to need to find our slope and our y-intercept. So the y-intercept is pretty easy. I'm just going to read that right off the graph. I have got a y-intercept of 4, and then I'm going to have to calculate the slope. So let's start with that step. This time, in order to calculate my slope, I'm going to use my y2 minus y1 over x2 minus x1 formula, which means that I have to pick 2 coordinates. So I'll pick this one, my y-intercept. That's an easy coordinate to read. It is 0, 4. That'll be my first coordinate. And for my second coordinate, I might do this one right here. So that is 10 and 6. An x value of 10 and a y value of 6. That'll be my second coordinate. I'll then plug that into my formula. So y2 minus y1. So I'm going to take my y value from my second coordinate, which is 6, and subtract the y value from my first coordinate, which is 4. So 6 minus 4. And then I'll do the same with my x coordinates. So my second x coordinate is 10. My first one is 0, so 10 minus 0. So that gives me 2 over 10, or 1/5, if I put it into lowest terms, as my m value. So now I'm going to go back over to my equation here and plug in my slope of 1/5. Keep my x, and my y-intercept of 4. Okay, so that is my first step. My second step is to then plug in my known x or y value, which is this 15.7. In order to do that, I have to figure out if 15.7 should go where the x is or where the y is. So in this graph here, time is across my x-axis. So x is going to be the how many minutes it's going to take. And because distance is on my y-axis, this distance at 15.7 kilometers is going to be my y value. So my second step now is to plug in my 15.7 where the y is. If I was given a time instead and asked how far I could get, I would plug the time in where the x is. But in this case, I am going to solve for x. So that is step 3, is to just start solving this thing. So in order to do that, I'm going to start by moving my +4 to the other side. So I will subtract 4 and subtract 4. 15.7 minus 4 is 11.7. And that leaves me with 1/5 x. And because I have 1/5 times x, I can divide by 1/5 to cancel it out, and then divide by 1/5 on the other side. When I plug that into my calculator, I'm going to plug in 11.7 divided by, and then in brackets, 1/5, and close my brackets. Just like that. And I'll get 58.5. So my answer is 58.5 minutes. Okay, so step 1, find your slope and your y-intercept and plug them into your y equals mx plus b formula. Step 2, plug in the value you're given where either the x or y is. Make sure you know which value actually going in as. And then step 3, actually solve using opposite operations if necessary. Okay, that was a longer lesson, but let me know if you have any questions.